Hi. Now what I'd like to show you in this video is how we prove the variance, or var(x) for short, of the distribution, the continuous uniform distribution. And what I've got here is the probability density function for it. F of x equals a constant k, which in this series I've shown you is 1 over b minus a, where x is defined between two limits a and b, and it's 0 otherwise. So how do we work out the variance of x for a continuous random variable? Well, you should be familiar with this formula, that the variance of x is equal to e of x squared minus e of x all squared. Now, on that basis, we already have talked about what e of x is, the expected mean, and I showed you that e of x for a continuous uniform distribution is the mean of the values a and b, in other words a plus b divided by 2. Now to work out e of x squared, so that we can put this into our formula up here, e of x squared is equal to the integral of x squared f of x integrated with respect to x between the limits a and b. And so if we substitute into this formula f of x, we've got our integral going from a to b of x squared times f of x between a and b, which is the constant k, and we're integrating that with respect to x. So if we integrate x squared with respect to x, we're going to get x cubed over 3, or a third x cubed. And if I multiply it by k, then I get a third k x cubed. And that will be between the limits then going from a to b. So all I need to do is substitute b in and then subtract what I get when I substitute x as a. So we end up with k over 3 and then b cubed minus a cubed. So we've got e of x, we've got e of x squared, and we can substitute it into the formula for the variance of x. And if we do that, okay, let's just see what we're going to get. So we therefore have the variance of x, var(x) for short, is equal to e of x squared, which is going to be this constant here, times a third. So if I take the constant k to be 1 over b minus a, and I times that by 3, that'll be 1 over 3 bracket b minus a, and then if I times it with the b cubed minus a cubed, I'm going to end up with b cubed minus a cubed all over 3 times b minus a. And then I've got minus e of x all squared. Well, e of x is a plus b over 2, so if I square that, it's exactly the same as squaring the top. That would be a plus b all squared divided by the bottom squared. So if I square the 2, I'm going to get 4. Now what I can do is simplify this by putting both these fractions over one denominator. And they both the 3 and the 4 go into a 12, and then I'm going to have b minus a. So that would be the lowest common multiple of both 3 bracket b minus a and 4. So on the top here, I need to multiply the 3 by a 4 to get this denominator here. So I need to multiply the top and the bottom by 4. So I've got 4 lots of b cubed minus a cubed. And then for this fraction, I can see that I've got to multiply the denominator here by 3 and b minus a in order to get 12b minus a. So I need to multiply top and bottom of the fraction then by 3 bracket b minus a. So if I do that, I got 3 bracket b minus a multiplied by then the a plus b all squared. So we'll just extend that line out there. Okay? So next, all I want to do is start to expand this. So we'll just move this over here, this equals, because I can see this is going to be quite long. So what are we going to get? Well, we'll multiply through by 4 here, and we're going to have 4b cubed minus 4a cubed. Now for this bit, if I multiply the minus 3 into this bracket, no, I'll just multiply the 3 in, and I'll get minus and then bracket 3b minus 3a. We'll expand this second bracket, a plus b all squared. Well, that is a squared plus 2ab plus b squared. And then we've got the denominator, which I'm not going to expand. I'm just going to leave it as 12 bracket b minus a. Now for the top, we need to expand these two brackets here. So, and again, another long line. So we're going to have the first two terms, 4b cubed minus 4a cubed. Now if we start multiplying this bracket by minus 3b, so minus 3b times the a squared is going to be minus 3a squared b. And then we've got minus 3b times the plus 2ab, so it's going to be minus 6ab squared, minus 6ab squared. And then we've got minus 3b times the plus b squared, that's going to give us minus 3b cubed. Okay, so we've got to take care on this, or I've got to take care anyway. Now we go on to minus 3a, so that's plus 3a. Plus 3a is multiplied by the a squared, and that's going to give us plus 3a cubed. And then plus 3a multiplied by the 2ab is going to give us plus 6a squared b, plus 6a squared b. And finally we've got plus 3a multiplied by the b squared, so it's going to be plus 3ab squared. Just about made it there. All over 12 bracket b minus a. So we need to just clean up the terms now, gather them up on the top here. So what have we got? Well, if we look at the b cubed terms, we've got 4b cubed minus 3b cubed. So that's going to be just 1b cubed, or b cubed for short. Then if we look at the a squared b terms, we've got minus 3a squared b, and we've got plus 6a squared b. So it's going to be plus 3a squared b. Then we'll look at the ab squared terms, and we've got minus 6 of them here, minus 6ab squared, and we've got plus 3ab squared. So that's going to be minus 3ab squared. And then as for the a cubed terms, minus 4a cubed there, plus 3a cubed there, so that's going to be minus a cubed. And that's all divided again then by 12 bracket b minus a. Now this top is a well-known expression. It is exactly the same as b minus a all cubed. And you might like to expand that out. You can check it out. You'll see that you do get that. And that is all divided then by 12 bracket b minus a. And you can see now that the b minus a becomes a common factor. It cancels out here, and one of them goes out with the 3 on the top here, so that brings us down to a 2. So what we end up with is that the variance of our continuous uniform distribution is b minus a all squared divided by 12. And that's how you can go about proving it. Alright,